Welcome back. So today I'm going to be explaining the two-pointer algorithm from the ground up. So not just how to use it, but why it works and when to use it, and how to recognize problems where you should be using it. So after we understand the algorithm itself, then we'll apply it to a classic Leetcode easy valid palindrome. So first, let's get an understanding of what a two-pointer actually is. So two pointers is a technique where you'd use two indices to scan through data structure instead of one. So most of the time, so right here, imagine this is a data structure array filled with an element of anything. Most of the time in two pointer algorithm, you have a pointer starts at the beginning and you have a pointer that starts at the end. And you move them towards each other based on some rule or whatever you're trying to achieve. So instead of checking everything against everything else, you're shrinking the problem space from both sides with two pointer. So that makes it really powerful. So the big advantage of two pointers is efficiency. So each pointer only moves in one direction. So that means each element is touched at most once. So problems that might look like big O of n squared at first can be often solved in linear time, big O of n. So when should you think about using two pointers? So you should really think about using two pointers when you're comparing things symmetrically, as you'll see in the Leetcode problem we're about to do, or you care about the start and the end, or the structure of the data tells you which direction to move. So anytime you're really narrowing from both sides and you're thinking about that, two pointers should really be on your radar. You should really be thinking about it. So now let's go into this example here and let's see what this looks like in a real problem, how you apply it. So valid palindrome is a perfect example because the problem itself is symmetric. So let's read the problem first. So a phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. So given a string S, return true if it is a palindrome or false otherwise. So now let's understand the problem, what it's asking. So a palindrome is a word that or a phrase that reads the same forward and backward. But in this problem, remember, it says we're ignoring punctuation spaces because it says after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters. That includes punctuation and spaces and whatnot. Only numbers and letters is what they're looking at. So we're not checking the string directly. We're really checking like a filtered version of it. So let's look at the example here to get a better understanding. So we have example one, input. We have a man, a plan, a canal, and then we have Panama. And you can see there's punctuation and spaces between each letter. We have commas. We have a colon here. So the output's true. And look at the explanation here. They lowercased everything. They got rid of all the spaces and they got rid of all punctuation like the colon and the commas. So then they checked, is it the same forward and backward? Yes, it is. Then it is a palindrome. So visually, it does not look like a palindrome, but after you lowercase everything and remove the punctuation spaces, it is. So that's a challenge. We're not comparing characters. The challenge really here is to skip characters that we like don't want to look at while maintaining symmetry. So now, how do we apply two pointers to the problem now? So this is where two pointers like naturally fits. So let's just use this example here. Let's write it down here. So let's just write the original string. Here have a man, a plan, a canal, Panama. So now we would place one pointer on the left side, the beginning of the string, and then one pointer on the right side at the end, right, in the string. And then our goal is to move them forward or not move them forward. Sorry, move. Our goal is to move them inwards, comparing characters that actually matter. So while we're moving them inwards, we'll have like a skipping logic because we only want to look at alphanumeric characters. So if a pointer lands on a character that isn't a letter or number, so if it lands on this colon or a space here, then we don't compare. We move the pointer until it lands on something valid, like a number or a letter. Only when both pointers are on a valid character do we actually compare and see. So just let's go over the full algorithm in plain English here. So while the left pointer is before the right pointer, we would move the left pointer until it hits a valid character, move the right pointer until it also hits a valid character, and we start comparing the two characters, ignoring case. If they're different, immediately they're not a palindrome. If they match, we keep moving them inwards and checking. So this works because each pointer only moves forward. We never backtrack and we never recheck characters. That's why the runtime is big O of n, and the extra space is constant. So now, with that, with the two-pointer idea clear, the code is just a translation of that logic. So let's just jump right into the code here. So now we can apply our logic into actual code here. So now let's just get started. So now you want to define two pointers, one on the left side and one on the right side, one at the beginning of the string, one at the end of the string. So let's start with defining those. So we have a left pointer, and then we have a right pointer. Left pointer will start at the beginning of the string, index 0, and then the right pointer will start at the end. The right pointer will start at the end of the string, at length of string s minus 1. So now that we've defined our pointers, now let's make our while loop here. So our left is less than right. So this loop runs as long as the pointers have not crossed. So if left crosses right, that means we've compared everything and we need to compare and nothing really failed. So left being less than right actually is basically saying there are still characters left to check. So now that we have that loop, now we handle the important rule now in this while loop. Ignore non-alphanumeric characters. So we have to write another inner while loop. So while left is less than right and not the string s at index left, the pointer left. The character at pointer left is alphanumeric. So Python does have a function to check if a character is alphanumeric and it returns a boolean, true or false. So that is really helpful here. So what this will do is we're ignoring alphanumeric characters. So the while loop is saying as long as we haven't crossed pointers and the left character is not a letter or number, skip it. So we keep moving forward. We keep moving the left pointer forward until it lands on like something valid. So if this is true, then if the condition is met, we increment the left pointer by 1. Keeps moving inwards. And now we want to have this same idea on the right side. So another while loop. So while left is less than right and not string s at the pointer, the right pointer, not alphanumeric. Alphanumeric. So if this condition is met, that means we also got to move the right pointer inward. So again, let me just say what the loop is saying. So as long as we haven't crossed pointers and the right character isn't a letter or number, we move the right pointer left. So now, remember the right pointer is at the end of the string. So we decrement by 1 now. So this moves the right pointer 1 step inward. And also both of these inner while loops, because it's in a loop, it can skip a whole run of punctuation or spaces. So now that both pointers are guaranteed to be sitting on valid characters because of these two conditions, we can compare them now. So we can call, there's a dot lowercase method on both, so the comparison is case insensitive. So we can do an if statement here. If s at the left pointer, and then now we're guaranteed to be on a valid character, alphanumeric character, then we can lowercase, and then if that is not equal to string s at the right pointer, we also lowercase that. So now here we're just getting rid of anything that's not true. So all it takes is one letter to not match for the palindrome to be broken. So we're just going to get rid of this case here. So if they don't match, we can instantly say the string is not a palindrome. And we can just return false immediately, because one mismatch, like I said, is enough to fail. So let's just, here we'll just return false. And now outside of this, if they do match, now we can just move inward again. Left, increment left by 1, and then same thing with right. Decrement, move them both inwards by 1. And then now, then the loop repeats. This loop will just skip junk characters, compare valid ones, and then just keep moving inwards based off that. So in the end of this loop, if we finish the loop without returning false, that means we never found a mismatch, right? So the string must be a palindrome. So then at the end, if this loop fully runs, then we can just return true at the end. I didn't capitalize this. So now if we run this, it should work. Yep, there you go. So work. So now this is how two pointers work and how to apply them to problems.